So what is the log base 9 of 27? It is the exponent or power you would raise 9 to get 27. So if this is a question mark, what is it? It is the power. You see where I put the question mark? I put it where the power of the exponent is. It's the power you would raise 9 to get 27. What is that power that you would raise 9 to get 27? It's 3. So this is kind of telling you this is the number that goes right there. It's the power you're going to raise this base to get up to 27. So this thing's 3. A clever, fancier way of doing the same thing is to say, okay, I want to know what this is, so I'll just call it something like X. Instead of question mark, just call this whole thing X. But what does X do? Well, it's that power that you would raise 9 to get 27. And when you write it this way, I think you would see, well, okay, it's got to be 1. It's got to be a little bit bigger than 1. It can't be 2 because 2 is going to be 81, and so on and so forth. Now, can we do this? Well, do you remember that if you have a fractional exponent, the denominator is the root? And so if we put a 2 here, that's going to take the square root of 9. That's going to make it 3. So if I were to put a 1/2, this would just be 3. It would be the square root of 9. But I want 27. So I could put a 2 here, and that makes it be 3, and then what I put up here is the power of the 3, and so what I want is a 3/2. Let's take a look at this and see if it makes any sense. Is 9 to the 3/2 27 power? Is 9 to the 3/2 power equal to 27? Well, yeah, because we do the square root first, and then take the third power. The square root of 9 is 3. 3 to the third power. 3 times 3 times 3 is 27. So this is 3/2. This is a logarithmic equation because it has a logarithm in it, and we're asked to write it as an exponential equation. Well, this whole thing is a power. So this 8 is a power. So we're going to have something to the power of 8 equals something else. A logarithm is a power. So when we have a logarithm, we write it as a power. Now what does this power of 8 do? It takes the base of c, so we put c down here as the base for the exponent 8, and it turns it into m. m is the final answer. So this equation, the log base c of m equals 8, is just another way of saying that this base to this power, remember a logarithm's a power, equals this answer. These are interchangeable, and one is sometimes easier to use than the other. This is the one we have the most experience with. The problem says just simply write this down. It doesn't say to try to worry about trying to solve anything, so we're done. Here our directions are to take this and not try to work on it or simplify it or do anything, just rewrite it. Instead of an exponential equation, an equation with an exponent, to put it as an equation with a logarithm. So let's start off with the log. Now the logarithm, what's the base here? Well, the base for the power of 1/4, the base is 16. So the log base 16. Then we need the final result, that's 2, equals, and this logarithm is an exponent. So the thing that's over here should be the exponent, and that's 1/4. So we're learning how to go back and forth from exponential equations here to logarithmic equations here. And this would be the final answer for 69. Here we're asked to solve this logarithmic equation, so a good way of doing that is to turn it into an exponential equation first, and then hopefully we'll know enough to be able to solve it. So how do we write this as an exponential equation? Well, this is the base for the exponent, and the logarithm itself is the power. So this is the power. And then this is the result of this base to this power. But we kind of know how to do this. We kind of know that we take the 1/5 power first, which is the 5th root, and then we square that. So what number is the fifth root of 32? What number can you multiply by itself 5 times and get 32? Well, it's 2. So this piece right here is 2. And 2 squared is 4. And so x equals 4 is the solution to this logarithmic equation.